Welcome to a discussion on magnetic effect of current. We'll define what a magnet is first. That which attracts other materials, congenial materials, is called a magnet. A magnet is a material that produces a field that attracts or repels other such materials of magnetic nature. Lodestone is a naturally occurring magnet. It attracts materials like iron, nickel, cobalt, etc. Two things we have to remember, we have to understand before we go deep into this discussion is, one is current. What is current and what is its magnetic effect? An electric current is a flow of electric charge in a circuit. In a circuit, there will be a flow of electric charge. If you take a cell, connect it to a bulb, you will see that from the negative pole, the electrons starts flowing into the bulb. It illuminates a filament by producing heat and light energy and returns back to the positive pole. This is a simple circuit with a light. We'll look into what magnetic effect is. A magnetic effect of electric current is actually a magnetic field that's a vector field that describes the magnetic influence on moving electric charges, electric currents, and magnetized materials. A magnetic material will have a magnetic field, a flow of current will exert a magnetic field around its conductor. And that is really important. A magnetic field is a vector field that describes a magnetic influence on moving electric charges, electric currents, and magnetized materials. Thus, we understood that a magnet, when subjected to a field of electric current, can cause a movement. Kinesis, we call it. It can produce movements. Power produces movement. And at the same time, a movement can, if done in a proper field, can produce energy also, induce energy also. Properties of a magnet we have to see. A free suspended magnet always points towards the north direction and south direction. The pole of a magnet which points towards the north pole, north direction, is called north pole or north seeking. And you can go to the other end, that is seeking the south. It's called the south seeking or the south pole of the magnet. And like poles will repel and unlike poles will attract. Those are the properties of a magnet. Similar to effects of electric current also produces magnetic effect. And when a magnetic material is brought into the field of force of an electric current, it will interact and will exert some changes. These changes will cause some displacements or deflection. It just moves from north position to a convenient other position in the presence of an electric field. This shows that electric current produces magnetic effect. A current carrying straight conductor has magnetic field in the form of concentric circles around the carrying conductor. Magnetic field of current carrying straight conductor can be shown by magnetic fields. It's depicted as lines, and these lines are just concentric around the wire which conducts the power. The direction of magnetic field through a current carrying conductor depends upon the direction of flow of electric current. The direction of magnetic field gets reversed in case of a change in the direction of electric current. So it is depending on the direction of the flow of current, electricity. Let a current carrying conductor be suspended vertically and the electric current is flowing from south to north. In this case, the direction of magnetic field will be anti-clockwise. And if the current is flowing from north to south, and then the direction of the magnetic field will be clockwise. The direction of magnetic field in relation to direction of electric current through a straight conductor can be depicted by using the right hand thumb rule. It's also known as Maxwell's corkscrew rule. If you hold the conductor like this with the direction of the thumb showing the flow of current, then the flow of the electric field will be in the direction of the wrapped fingers. The fingers with which you wrap the wire, hold the wire, and the direction is this. That is the Maxwell's corkscrew rule. If a current carrying conductor is held by right hand, keeping the thumb straight and in the direction of the current, the current is in the direction of the thumb, then the direction of wrapping of the fingers shows the direction of the magnetic field. That's simple it is. Maxwell's corkscrew rule. If the direction of forward movement of a screw shows the direction of the current, that means the sharp end pointing towards the direction of the current, then the direction of rotation of the screw shows the direction of magnetic field. That's simple it is. Let us see some of the properties of magnetic field. The magnetic field, the magnitude of a magnetic field increases with increase in electric current. When you supply more electric current, the magnetic field will increase. When you reduce the electric current, the magnetic field will reduce. The magnitude of magnetic field produced by electric current decreases with increase in distance. And as you go away from the conductor, the wire, the magnetic field decreases. And if you go nearer, the magnetic field increases also, vice versa. And magnetic field lines are always parallel. They go parallel around the conductor. No two fields will cross each other. That's very important. When we study the theory of generators, power generators, no two fields will cross each other. A movement of a magnet within the field of a coil can produce power. That's a basic principle behind all generators.